Before we proceed with part 2 of this EVU mini course, let's take a quick look back at what we covered in part 1. Kinetic energy is lost when a car decelerates due to braking. In conventional ICE cars, kinetic energy is lost as heat during braking. In an EV, kinetic energy is recaptured by converting the electric motor into a generator. The torque or rotational energy of the wheels drives the generator, which produces electric current that recharges the EV battery. It's now time to examine the regenerative braking system and its major components. Of course, all of this is new tech, right? Again, the answer is no. The original patent for regenerative braking systems was offered by C.J. Paulson in 1908. So this is not new technology, although huge numbers of refinements have been done over the years. As we discussed in part 1, regenerative braking takes advantage of the duality of the electric motor. The core components of a regenerative braking system are the same components you learned about in earlier EVU mini courses. An energy source, which in the case of EVs is the battery itself, a motor/generator, and a control system that provides the intelligence necessary to affect the energy capture. The diagram on the right of your screen depicts the regen system components when they are passive. That is, when the accelerator is depressed and the car is moving forward. The battery passes power to the motor, which transforms the power into rotational energy that drives the wheels. Control electronics coordinates all of this. Now let's look at what happens when the driver takes his foot off the accelerator. Control electronics sense that the accelerator has been released. Electric power to the motor is cut. Rotational energy from the wheels becomes input to drive the motor, transforming it into a generator. Again, control electronics coordinates all of this. Bottom line, the flow of energy from the battery to the wheels is reversed during regen, as depicted in the diagram on your screen. The system components remain the same, but the flow of energy changes direction. The control electronics for a regenerative braking system is a combination of hardware and software that monitors the rotational speed of the wheels, determines how much torque is available to be converted into electrical energy, provides rotational energy as input to the electric motor, transforming it into a generator, conditions the electrical energy from the generator and affects transfer to the battery, and monitors other conditions, for example, the state of charge of the battery. A more detailed discussion of the technology that allows the controller to do its work, involving very technical images like the one shown on the right of your screen, is beyond the scope of this EVU mini course. Those students who would like to delve further should examine study guide materials for more detailed information. A few questions might be in order here. Are there situations when regen is inoperative? The answer is yes. If the battery is full, that is at capacity, regen is disabled because there's just no place for the electricity to go. How does this happen? The regenerative braking controller monitors the battery charge and will only invoke regen if capacity exists for a recharge to happen. Can the driver control the amount of regen? In some EVs, yes. For example, in the Tesla Model S, regen can be set to either standard or low. On the low setting, regen is less evident to the driver. And are there other limitations? Regen is certainly less efficient at very low speed, and although it serves to reduce speed nicely, regen is absolutely no substitute for conventional brakes for emergency stopping. The diagram shown on your screen is representative of a typical PHEV regenerative braking arrangement. During acceleration or steady-state driving, an ICE motor and/or an electric motor, depending on the PV architecture, drives the wheels and propels the vehicle forward. At slow speeds, the PHEV may be in battery depleting mode and the ICE will be inoperative. During braking, the ICE is disengaged and the rotational energy of the wheels becomes input to the electric motor, transforming it into a generator that passes electricity back to the PHEV battery. The first time you drive an EV with Regen, you'll encounter a new and slightly odd experience. When you remove your foot from the accelerator, the car slows perceptibly without touching the brake. It feels slightly like downshifting a conventional manual transmission, but much smoother. You can come to an almost complete stop without ever touching the brakes. After some practice, you unconsciously begin to judge stopping distance and remove your foot from the accelerator accordingly, allowing Regen to do all of the braking work for you. Your brake lights will come on during Regen according to an algorithm defined by the EV manufacturer. In some cases, brake lights are triggered by the number of kilowatts that are generated as Regen occurs. If the kilowatts generated are below a certain number, for example, applying Regen at very low speed, the brake lights will not come on. The EV comes to a near stop, 2 to 3 miles per hour, without touching the brake pedal. Let's summarize. Kinetic energy is lost as heat when a conventional vehicle decelerates due to braking. An electric motor can be either a motor or a generator, depending on the type of input it experiences. And this provides the basis for regenerative braking. Regen allows an EV to recapture kinetic energy and transform it to electrical energy to recharge the battery. Regen represents a different driving experience, one that you adapt to very quickly. Within weeks, you won't know how you ever drove without it. It's really a very cool feature that distinguishes EVs from ICE vehicles rather nicely.